The integral test and the geometric series formula both give us ways to tell whether a series converges or diverges. So now we can look at, let's say if we had a sum, and the sum ends all look like a to the power r to the n minus 1. Does this converge? Well, I need the absolute value of r to be strictly less than 1. That was my geometric series test. What about series where the formula for the sum ends is actually some nice thing that I could try integrating? So I need a function here which is continuous and decreasing and positive. Then I would try integrating. I'd need an improper integral. And so whatever I get here, if the integral converges, then the series converges. If the integral diverges, then the series diverges. So these are two different kinds of series that we can try to figure out convergence, right? Whether or not these series converge to some number. The next thing in this section has to do with comparing series to other series. So now that we've got sort of a foothold here, we've learned to check convergence for certain kinds of series. Let's look at other ones that almost fit those formulas, but not quite. So the comparison test has to do with a series that almost looks like something else that we know. Here is the series starting at n equals 1 and going off to infinity. 1 divided by 2 to the power n plus 1. Okay. Well, that almost looks like a series where I'm adding up all of the fractions 1 divided by 2 to the power n from n equals 1 to infinity. Well, that would be a geometric series, and I would know that that converges just automatically using the formula. But I don't have that for this series. I've got something that's close, but not the same. So what we can do is we can say that all of the fractions 1 divided by 2 to the power n plus 1, all those fractions are going to be less than the corresponding fraction from the other series, 1 divided by 2 to the n. So the series that I want consists of, a list of numbers. Each number on the list is less than something from the list of numbers for a geometric series. And I know that that geometric series converges, so stands to reason that this other thing that I've got converges as well.